Hi, I'm Zuzanna Opała, and together with Mikołaj Pacek, we will present our work on curriculum and decentralized learning in Google Research Football.
Hi everyone! Google Research Football is a novel environment modeled after this popular game designed to be an RL testbed. While physically plausible, it abstracts from low-level details. Agents can take high-level actions such as running and shooting ball, and so complex strategic behaviors can emerge. We trained our policies in single and multi-agent setup. In single agent setup, we play a full 11 versus 11 match, controlling a player that is closest to the ball. In the multi-agent setup, we trained on a simpler 5 versus 5 scenarios where we control all of the players except goalkeeper. In single agent setup, pure RL methods worked, but we found their sample efficiency unsatisfactory. We created a difficulty curriculum where we continuously increase opponent's team difficulty, which corresponds to reaction time, when the agent performs well with current difficulty level. The plot shows difficulty level during standard training and our curriculum. The table compares these two approaches on a fixed opponent. We found that this curricula helped achieving higher rewards in less time steps.
Training agents in the multi-agent setting using only the goals as the rewards is exceptionally challenging, and we are not able to achieve it using pure RL. To tackle this problem, we have introduced two curricula. The first one, based on gradually increasing the number of opponents, and the second one, on gradually more complex scenarios. This curricula resulted in a similar performance, creating agents able to defeat the hard building bots. To further improve performance of our agents, we have decided to use self-play framework. We have trained our policies against previous versions of themselves. This approach led to development of more general behaviors, especially self-play agents were able to defeat not self-play ones. We tried two approaches to multi-agent training, centralized and decentralized. In the centralized setup, we have one central policy which controls all the players. In theory, in this setup there should not be problems with coordination. In the decentralized setup, each controlled agent performs actions separately. The setup is scalable and actions can be executed by, for example, separate machines. In our case, we have one network that separately controls all the players. After training both architectures the same amount of real time on the same machines, it turned out that the decentralized policy was much better. It is surprising, as we would expect better coordination and strategy from centralized one, although similar results can be also found in literature. We observed that in centralized architecture, two of the players have specialized action sets and superior performance, while the other two have action distribution close to random. We think it was related to the initial placement of the players. The two capable players were the attackers, starting each episode near the ball. Swapping players' starting positions, however, resulted in all the players taking very similar actions at the same time, like the network had problems to distinguish them. We were also able to successfully apply imitation learning, where centralized policy was copying actions from the decentralized one, but we were unable to train it further without loss of performance. None of these approaches were able to outperform the decentralized policy. Throughout the training, several interesting behaviors emerged. For example, our centralized policies loved to set the offside traps. They also used one-man army, especially against built-in AI. When one-man army was not enough, the policy turned to horde attack, where all the players were chasing the ball in the tight group. Our best policies used some sort of flank attack, where the agents ran with the ball closer to the side of the pitch. More interesting behaviors, as well as information about our training setup, can be found on the project website. Also, Kaggle competition in this football environment have just started, so if you're interested, you can check it out. Thank you for your attention.